going on, guys? Vlad with eenthusiast.com here, and in today's video we're going to be looking at multi-threading in iOS 3, Xcode 8.0. So as you can see, I have a very quick demo application that we're going to be building in today's tutorial, and if I click on an image button, it will fetch a different image, a very large file. So as you can see, I got the activity indicator showing that the app is fetching an image. And also an important thing to notice is when it does so, you can still play with the UI. Here's a slider for demonstration purposes, but essentially it's not blocking the UI, so it's doing it asynchronously. And that is kind of the cornerstone of multi-thread programming. Before we dive into the code and into the app, I wanted to kind of give you an overview of what multi-threading is for those of you who are not aware. It is a concept where essentially you're breaking down your program into segments of code which are going to execute either in parallel or sequentially, depending on how you want them to be executed. And the way, or I guess the best analog that you can think of is, imagine your computer right now, which has 2, 4, or 8 cores, some 16, but your OS, what it's doing is essentially breaking it down and telling a certain programs, for example, your browser or your video codec, or I don't know, like an audio file player, to go and work on a certain core. So the OS is handling sort of which program can occupy or utilize which core. Well, multi-threading is a very similar concept in the sense that it is a program level breakdown of different functions, sort of like which thread is going to execute at which time. And what I mean by that is essentially you break down your program into threads, and you can specify based on priority which thread is going to execute at which time and which threads execute in parallel or in sequence. So what does it mean for a program, or why should you care? Well, essentially what's going to happen is you're going to do requests for data, whether it is, for images, maybe tweets, for example, or any sort of data requests, which is very common use. And what's going to happen is if you try and pull something very large in a non-asynchronous fashion, you are going to block the UI for the user on iOS. So what's going to happen is the user is going to click, for example, retrieve image 1, and they're not going to be able to move the slider. And we're going to be looking at that in the tutorial. But that's a very common application for asynchronous programming. And yeah, so you always want your applications to have this behavior when you are retrieving data, because otherwise they're going to see the app, they're going to kind of think it's bugged out, it's not working properly, and they're just going to leave. They're going to uninstall your app. So very important concept. There are quite a bit of changes made in Swift 3. The syntax has changed for the dispatch queue function. And we're going to be looking at all of that, so let's jump right in. Alright, so we're going to be creating a single view application. We're going to call it multi-threading tutorial. Click on next, nothing different there. Now I'm going to be creating a Git repository. You're going to see the code on your screen over here once I push it to my GitHub. So let's click on create, and you should have a blank project in front of you. So in our main storyboard, what we're going to show is essentially an image with 3 buttons and a slider. So let's pull that right over. Let's start with the image view. And we're going to resize it just to a fixed height. So let's spin it to the top, left, and right, and give it a fixed height of 300. Press enter. We're going to update the frames to make it as it should. Let's create the buttons. Button. Pull it right here. All the way to the margins. And let's make it of a bigger size. 30. Okay. Let's rename it to image 1. Control C, Control V to copy and paste. Control V once again. Clicked on Control B by mistake. No worries. Everything is good. Alright, image 3. So 3 buttons for the images, and let's drag out a slider. This is just for demonstration purposes. Essentially, we want to see that we are either blocking or not blocking the UI. So a very good way to do that is have a slider. Let's select all 4 of our objects and put them in a stack view. Big fan of stack views. And distribution we're going to set equally. Let's add some spacing between the elements. We can play with the styling some more, but let's create our constraints. 8, that's fine. 0 from the right and a 0 from the bottom. So that should work. Let's quickly update the frames, make sure everything's okay. And let's just launch it on iPhone 7 to see what's going on with the UI really quickly. Obviously, we're not going to have an image because I don't have anything as a default in there, but we should be able to see all of the buttons and the slider. Okay, cool. So next thing is going to be we're going to be pulling the outlets for the buttons as well as the image onto our controller. So let's go into split view. Our view controller is already linked. If you remember from my previous tutorial, which is going to be on the screen right now, you need to do that if you create a new file. But in this case, it was already linked for us with the new project. All right, cool. So let's start with the image. Control drag, and this is going to be my image. Connect. Next, we will have the buttons. So UI button. This is going to be an action because we're going to be pressing the button. Change this to a UI button, and name is button 1 pressed. Connect. Similarly to connect button 2 and button 3. So UI button 2 pressed. Connect, and button 3. Not sure why it's a bit finicky that way, but yeah. Add some extra lines, action, UI button, and button 3 pressed. Click on connect. Alright, so we're obviously going to need a function which will update the image. So func update image, and this will receive the essentially the number of the button which was pressed. And inside of this function, what do we want to do? So essentially, we want to have different URLs for each button, and based on which button was pressed, we'll retrieve a different image. So let's quickly create the calls, switch out of this view, come back to the view controller. So update image, and this will be 1. Here we'll have update image button 2 and update image button 3. So we're going to be calling with this function with the 3 buttons that we've created above. Just quickly move this up here. And what I want to say, so there's a couple of ways of doing this, but essentially we want to, based on this button identifier, we want to fetch a different URL. So what I'm going to be creating is a variable which is going to hold a URL. So image URL equals to a URL, and this requires a default constructor. So let's create it as null for now. So it's essentially not going to have any URL as it gets instantiated. And then we're going to switch our button, right? So we're gonna have 3 different cases, and in case of default, we're gonna break. So case 1, case 2, case 3, right? So 3 different buttons, 3 different cases, and I've already pre-programmed these URLs. So what I'm going to be doing is essentially copy pasting just to make this a bit quicker. These are images that I've gotten through Google, so you can utilize them for testing purposes. And so this will be URL, URL, and URL. So 3 images, depending on which case we are going to use. What is going on? Yeah, so sorry, this needs to be exactly that. Okay. So we assign, essentially what I'm doing is assigning a specific URL depending on which button has been pressed. And then what I need to do now is pretty much retrieve the image. So make a request to the web to retrieve the image and display it for the user. The way that's going to be done is through a fetch request. So ns data. So through a contents of our URL, so this is going to be image URL. We know that it will be there, so we're going to force unwrap it as a URL. Okay, and then if let image data equals to, so if we do have this working, so if it allows us to assign it correctly, if let image data equals to fetch, we are going to do a self that image, so my image dot image equals to UI image of a data, image data as data, and we don't need this scale CG float. Okay. So this should be fine. Let's see, actually one more thing, we're gonna probably encounter an error, and I want you to see the troubleshooting right there, but let's see what the request does. So the issue here is essentially we're using an HTTP request, and so this by its nature is not an HTTPS request, so it's doing a non-secure fetch of data. And what the app is telling us is the app transport security has blocked an HTTP resource load since it's insecure. And the way to fix that is you go into your info.p list, click on your plus, app transport security settings, create that, click on the little arrow, click on plus once again and allow arbitrary loads. You will need to set that to a yes. Okay, save really quick and relaunch the application. So now you should be able to build and fetch that insecure data. It is a feature by Apple which essentially blocks non-secure requests. And as you can see, the images are loading, but they are not being loaded asynchronously as it was with the other application. So let's give it just a second here, and our image should appear. Any second now, any second. There we go. So the image is appearing as it should, but if you can, so let's say the UI is currently responsive and I click on image 1, right now I can't do anything else. I can't click on images. I can't use any of my UI functionality, and that's a really, really bad practice. So UI is being blocked by those fetches, and as you can see, it kind of works, but then it executes after the fact that it retrieved the image. So just very, very poor performance from a UI standpoint. So we're going to be fixing that with multi-threading. So let's come back to the view controller. Okay, so this is going to be the section which is going to be asynchronous, essentially, and that's what we want to encompass with our thread. So what we're going to do is dispatch queue.global. Quality of service. So you can read the documentation in depth and kind of understand what different quality of service means. but essentially it has to do with which priority you want to utilize on this particular thread. And in this particular case, this is going to be a user-initiated action, so they've clicked something and they want to retrieve a certain amount of data. You have stuff like you can do it in the background, you have UI type of stuff which is going to go on the main thread, so you want to always pay attention to your quality of service, but this is going to be dispatch quality of service that user initiated that quality of service class that async, and we're going to be putting all of the following code inside of this. So let's close it right here, quickly tab our implementation, and essentially this also needs to be tabbed. Let's do that as well. Cool. So what we want to do asynchronously is get the URL and get the data image, but after we want to update the UI, so the display of the actual image on the main thread or on the main queue, so to speak. So what we're going to have to do is essentially dispatch a main queue request from within our user initiated request in order to update the image. So the way we are going to do that is dispatch queue dot main dot async, and we're going to be putting the rest of our code in here. So let's add our tab and close this dispatch queue. So at this point, what this code is doing is it is requesting the image on an asynchronous thread, and then it's updating the image view on the main queue, which is the best practice for any UI updates. You can force a UI update on a different queue, but it is highly discouraged, and you should not be doing that. It is bad practice. So let's see right now. If I press on image 1, as you can see, our thread is doing, it's fetching asynchronously. We don't have any hangs in the UI. We can always play with our different buttons. We can always play with the scroller. There's no blocks essentially, and our app is completely responsive. The user, if you had different windows, maybe a settings tab, maybe the user doesn't want to see this image anymore, they can navigate away without any problems, and this is all done asynchronously. Alright, so in the last section of this tutorial we are going to implement a spinner. So let's go back to our main.storyboard, and this is called an activity indicator. So activity indicator view is going, we want to center it on our image view, and okay, let's just style it really quick. Large white, let's make it of a different color because we're not going to see it if the image is not there. Let's make it a nice cyan or a light blue. It will be animating, it will be hidden when it's stopped. And now to add the constraints. So if I simply go and add the constraints as it is right now, it will cause us problems. First of all, let's move it up right below the image. It's very important to have it below the image and not above the image because it's going to be essentially overlaid. So the activity indicator, you want it to be in front of the user versus the image being on top. So let's add the constraints like so. So imagine you place it right here. I can click on control and drag to the image. You can either drag it here or you can drag it to in the scene. So image, and we are going to center horizontally. You can do that with the container as well, and then center vertically. So that's going to create a, as you can see, the grid for our activity indicator to be positioned right in the center of the image and not in the center of the main top view. So what we're going to have to do is add an outlet to our controller. Let's add some spaces, control drag. It will be an outlet, and let's call it activity indicator. Click on connect. And now what we essentially need to do, we need to tell the app when would you like to run this activity indicator. So by default it's running. So we want to, as we load, what I'm going to add here is self.activity indicator dot stop animating. So at first, as we get onto the view, it's going to stop animating, and then we want to as we dispatch our our request, we want to start animating. So this is the function in which we animate. So this is where we want to put our activity indicator. Dot start animating. Okay, and once the request has completed, so once the image was successfully fetched, and this is done over here, we want to stop our indicator from animating. So stop animating. Let's save that and see what we have on our simulator. Okay. All right, so as you can see, image 1, the activity indicator is working, UI is still working. So the benefit of this is that the user is actually seeing that something is going on in the background. They're not just left with, before we would just click the button of the image, and in the background we would be getting the image, but the user doesn't know that, right? So they're just seeing a blank screen or the same image, so they don't know that the image is actually loading. So highly recommended to use activity indicators to show the fact that we are changing or we are fetching data in the background. So that will be all for this particular tutorial. If you have any questions, comments, and or requests about multi-threading or any other iOS programming that you would like to see, make sure to leave a comment. If you've liked the video, if you've learned something new, make sure to like, subscribe to the channel, and see you guys next time. Thank you for watching.